Good morning and welcome to this workshop. It's the fourth workshop in a series of consultation workshops that we have started after the summer. My name is Stavros Stamatukos. I'm working for the digital team at the DGNR, and I'm part of the team that we are preparing the strategic roadmap for digitalization and use of artificial intelligence in the energy sector. This workshop today is very important to us. As I said, it comes fourth in a series of workshops that we have started, but that is two sectors that they are extremely important for us to understand the needs of AI, the state of play, current barriers, and what the European Commission can do to accelerate deployment of AI in this sector. But before we start in the details of this workshop, let me give you a brief introduction of the previous discussions, just to set the scene and also align expectations from today's discussion. So this consultation process started early September, mid-September. We had the first workshop where we deep dived into the AI foundation models. So what are the foundation models, how they can be developed and serve different sectors of the energy value chain. So sector-specific foundation models are a new reality. They're still in early development stage. We don't have so many, at least in Europe, but the potential is great for the energy system, given the increased complexity. And all participants concluded that indeed we need to act faster as Europe, on the policy and regulatory side, but also on the industry side. Data is fundamental for the development of foundation models. New kinds of data are required. New types of sharing frameworks must be created or adapted to this new reality. Synthetic data sets, federated learning, or cloud solutions are ways to that direction. But what is also needed that is new cooperation structures because of the concrete complexity of the development of these foundation models. We need cooperation structures for defining common goals and governance frameworks for data sharing, for training, validation, and testing of these foundation models, especially when these are to be integrated in critical energy infrastructures. And what is also needed is compute capacity, which is currently being developed in Europe. We are lagging behind to the US or other jurisdictions, but we have very good plans. So you have heard about the AI factories and gigafactories that they are currently being funded and developed by the European Commission. So the compute capacity is coming to Europe to serve this purpose of developing, training, and testing these foundation models. And finally, skills are generally considered to be a challenge, especially in the energy sector. The second workshop in the end of September focused on the risks. What are the risks of development of and deploying these AI solutions in the energy system? And what we heard coming again and again in the discussion is that the biggest risk is the risk of not acting. And to be more precise, not acting fast. It is very important for Europe to build on the momentum of AI revolution and create European solutions that they are developed in Europe with European know-how and serve the energy transition that we are aiming at. Human in the loop and human oversight are essential, especially for critical energy infrastructures. Systemic testing and validating are key in mitigating risks, and obviously sharing of best practices and lessons learned from near misses, mistakes and incidents are part of a continuous monitoring process. Finally, what came up as an important need, especially from our side as well, or from the policy side, is regulatory certainty and clear guidance on the implementation of the European regulation, for example, the AI Act. Then, mid-October, we had a third workshop deep diving in the sector of grid management and how the foundation models can be used to accelerate the smartness and digitalization of the European grids. We heard from system operators how they're currently approaching the development of AI foundation models and testing. And what came up again from that workshop, if I can use one conclusion, is the new reality of sharing data in a secure and trusted environment, cross-border and cross-industry. So we are taking this point from this workshop, and with the upcoming strategic roadmap for digitalization and AI in energy, that, as I said, we're currently preparing and will be adopted early next year, we're trying to address this challenge. And with that, I come to the objectives of today's workshop, where we deep dive into different sectors. And one is the integration of renewable sources into the energy system, and the other is the energy management in European buildings. We want to hear from you, and hopefully we can have a dialogue after the presentations. What is the state of play? What are the most promising applications or use cases in these two sectors? And what is their potential impact on operations, manufacturing, maintenance, or forecasting? What is the potential of different AI solutions? And if foundation models is also a new reality in this sector, as it is, for example, in the case of managing power grids. What is the scope of data sharing across industries and across players? This is also a very important element that we want to address in the strategic roadmap. So we would like to hear from you today. And finally, what are the barriers that the sectors are experiencing today in developing and deploying AI solutions? Is there a need for further cooperation, regulatory clarity, or European or national policy action? That was a short introduction from my side. Before I pass on to the moderators to kick off the sessions, I would like to inform you that we had a public consultation running for 3 months, since the beginning of August until yesterday. We are very happy that we received a great amount of responses, of feedback from industrial players. So several hundreds of useful contributions that we will start to analyze already today. And hopefully in the next 2 weeks, we will have some first results that will be presented by our commissioner and executive vice president Henna Virkkunen and our commissioner Dan Jorgensen in an event that we will organize on the 19th of November here in Brussels, and will be broadcasted online for those of you who would like to follow. We will circulate the link after the event today. So after this brief introduction, I will pass the floor to Volker Berghout, a research fellow from Fraunhofer, and to moderate the first session that will deep dive on the use of AI in the renewable sector. Thanks a lot, and Hope that we have a very good discussion.
Right. So again, thanks, Stavros, for introducing the workshop and starting the session on the use of AI in the energy sector, on renewables and the building sectors. In this session, we will talk about the application in renewables and renewable integration. And I'm happy to, well, moderate the session. I'm Volker Berghaut, working with the Fraunhofer Institute for Energy Economy and Energy System Technology on digital ecosystems. So I'll guide you through the session, and I'm happy to have a very nice crowd of experts on the panel. That is Norela Constantinescu. She's acting director of the Innovation and Technology Center at IRENA. Hilde Newton is COO from Wind AI. Johnny Blumberg is Chief Product Officer at Emulate Energy. And Matthijs Dratan is founder and CEO of Ogre AI. So welcome to the session, and let's dive into our topic. And I'll start with a question of what are you working in? What is your field of expertise, and what do you see as the main potentials for AI solutions for renewables in your sector? And maybe Norela, we'll start with you from an associations perspective. So I'll give the floor to you.
Thank you very much, Volker. First of all, IRENA is not an association. It's intergovernmental agency. So the governments are the member states, so it's not really an association. And we cover, so we have a global coverage with 170 countries. In terms, because I don't know how you will organize the flow, in terms of what we are working on in the space of digitalization and use of AI, it's of course on renewables and renewables integration. We just made an assessment and we released a report for G7 Canada presidency last week. So we looked actually at 5 value-added clusters we have identified, and for digital and AI solutions. And of course, I should recall that renewables globally, but also in Europe, the wind and solar are the major deployments actually, and therefore, the focus was on the variability on a generation side, but also because we go towards the electrification, and I understand that the European Commission next year will also have actually an electrification proposal. So we also have the electrification dimension, which also brings variability, and therefore integration means also a lot of complexity. So coming back, and you stop me when I talk too much. Coming back to the 5 value clusters we have identified. So first of all, monitoring. And here, what, of course, we mention, it's actually the data collection. Of course, you can, because we looked also in emerging and developing economies. So this is not the case only for the emerging and developing economies. This is also the case for certain countries, including the G7 countries. So it's important to have, of course, the data, because without data, it's we cannot do anything. And therefore, certain technologies, of course, the smart sensors, the SCADA system, the digital twins, the satellite imagery, especially, of course, for renewables. So this is the first group of elements we have identified. Then, of course, for renewables, the forecasting.
Norela, you're taking us through the 5 clusters right now. So if you do that, maybe just go. Can you mention maybe go fast through the topics that are in there, and maybe we dive deeper into it in another round?
Okay, so forecasting, operational optimization, on the demand, end use automation, and transparency. So 5.
Okay.
And we link them with different benefits for the policies in the countries.
Perfect. Okay, so that gives a very good overview about what areas of interest there would be from the report. So I'd like to continue with you, Hilde. So in the wind sector, what are you working on? What potentials do you see?
Yes, first of all, thank you so much for being here. So I'm Hilde, one of the founders of WindAI, and we're a platform for wind development. And in WindAI, we've seen we work with the first part of the value chain. And we've seen in the planning and design phase, we have seen that digitalization and AI can speed up the processes considerably because there's much more data available. It's easier to navigate in the data, and therefore also companies can identify risks earlier. And also with more information and speed, it gives us a much higher chance to compare different scenarios and see across different projects and what's best. So we, in the early phase of the development, this is really effectful.
Okay, thank you very much. And Johnny, Emulate Energy, what fields are you working on? What potentials do you leverage with AI?
So Emulate is we're a Swedish, you say, clean tech company working with many, say VPP, but basically we connect different assets in the energy sector. And in this case, it's a lot households devices such as heat pumps and batteries, so forth. So we connect them, we aggregate them, we optimize them for the household owner, but we aggregate them to utilize that flexibility, let's say on different energy markets. Our main customers in this case, the energy retailer, but we are working with, let's say, all actors throughout the value chain. And from our perspective, I mean, we're utilizing AI throughout, but it's a lot about kind of, I would say, optimization and the data sharing across the different actors in the value chain that is important for us, and in order for us to use and work with predictable algorithms and so forth. So I think from our point of view, it's all about working with flexibility in the best way for the entire, let's say, energy sector.
Okay, thank you. So Matej, we're interested in your point of view there.
So first of all, thanks a lot for the opportunity and congratulations on the initiative. I run Ogre AI. I'm the CEO and founder. We are a company that has the vocation to do forecasting. And today we are helping all types of operators along the value chain to forecast different use cases. And we currently work in 15 countries, even outside of Europe. With the respect to the potential on the forecasting towards the value chain, there are quite a lot of things to say, but mainly it helps improve the forecasting accuracy for both PV and wind, for consumption forecasting, as well as for the, let's say, load and losses for the distribution and transport system operators. We see a lot of, let's say, yield or increased energy yield and reduced balancing and reserve costs, and a lot of, let's say, enabling technologies due to the AI. But of course, I can deep dive further into these as we go along. So thank you.
Right. Yeah, and actually, I think looking for impact and going a little bit deeper into certain applications, that's exactly what we are trying to do now. So what I'd like to ask you is, what specific potentials where do you see the largest impact and potentials that AI technology can make? And maybe you could also see what is on the short term relevant and is easy to achieve, and then on the long term, where are still challenges and barriers that need to be overcome to really have a bit larger potentials that are yet to come. Matej, maybe you just go on from there.
Sure. Let's go from the renewable side. So first of all, I mentioned it improves forecasting accuracy for both the wind and the PV. And at Ogre, we only use foundational models today, and we have built all our technology based on foundational models. We help the operators, and we have like 40 operators already working across multiple, let's say, regulatory areas. They all increase the yield and reduce their balancing costs, and it really supports them much better with their trading and revenue optimization. On the other hand, also for the renewables, we have seen other companies which are helping to detect assets which are underperforming early, and also they enable the predictive maintenance, which ultimately extends, let's say, the component lifetime. If we have to look at transport and distribution, then of course AI, and we're using it today to forecast the load and congestion, the losses, curtailment risk, and even voltage issues. And this greatly enhances the ability of the DSOs and TSOs to manage efficiently the grid, and especially those, let's say, DSOs which have a high adoption of prosumers. For this particular value chain, let's say, place, it enables dynamic line rating capabilities. It supports, for example, dynamic tariffs and predictive maintenance. And really, it not a dynamic tariff, sorry, it enables predictive maintenance and grid infrastructure and dynamic line rating. These are the two for the TSO and DSO side. If we look at the retailers who we help with the consumption forecasts, we do this much more accurately than they were doing traditionally. It also ends up with a higher yield and reduced balancing costs, but it also allows for demand shifting and dynamic pricing capabilities, and it also helps to coordinate smart devices, such as my colleague said very well, like heat pumps, for example.
Right. Thank you, Matej. And Johnny, maybe we stay on this retail distribution side for another point. So what's your take on the potentials?
Oh, I think just connected to what just Matej very, let's say, well described, so to speak. But I think that the balance here is that we, to be honest with you, some of the optimization that we do is actually, let's say, hurting other parts in the value chain. For example, increasing balancing costs when we do optimization for example, dynamic pricing. So I think that all in all, I think from our perspective, it's all about getting from that into we need to optimize, and not only for the consumer, the asset owner, but also optimizing, let's say, from the entire value chain's perspective, so that we minimize balancing, so we don't increase the balancing cost, for example, while still making sure that we can optimize and create value for the asset owner. In the end, it's all about creating incentives for asset owners. Now I am talking specifically a lot about consumers, but how can we create incentives for them to actually connect the devices so that they become flexible? So it's all about kind of, from our perspective, it's all about we need to make sure that we can create as much flexibility as much in the system, and that needs to be there in creating incentives, starting from the asset owner, but still kind of optimizing from the entire value chain.
Okay. Thanks. Hilde, for the wind energy sector, where do you feel things are working best?
Yes, I mentioned the early phases, and I mentioned reducing risk and faster development. So our customers actually report that they can do business cases 5 times faster than they did before. So I think that's quite amazing. And in the short term, this is affecting how developers can use their information internally more effective. But in the longer term, when we can share data across companies, this could also influence the whole industry moving faster. So yeah, that's good.
Okay, perfect. Good. Then what Stavros said in the beginning is that we are looking into, well, providing data and governance issues. So Norela, maybe from this governance perspective and making this use cases work and tapping the potentials from the 5 clusters and also from what participants have said here earlier. Have you looked into the governance needs that we use yet, or do you have suggestion on how to develop that?
So going a little bit back to your first question, so I confirmed that indeed the forecasting was one of the elements we have identified, like short-term win, as well as monitoring and control. We have an example on 50 gigawatt by using projects developed in different regions of the world, Europe, US, and Middle East. And we looked actually in how much would be the benefit for that. And most of the benefits in terms of savings and in terms of additional revenue are around 450 million, and they are related to the asset monitoring and control and asset maintenance. So this is an example which just confirm what was said before. Now, in terms of the governance, what we see as a need. So of course there are different layers. So the data and the interoperability, but maybe then we discuss separately this part. In general, for the stakeholders, what I think we have identified as a need for the governance, it's due to the different timelines, lead timelines of renewables, of grid deployment, and of the digital solutions. We see the need to put together actually these actors, so utilities, AI and digital actors, member states and regulators, in order to align, all these different, is not only views but also solutions on one hand. And then in order to raise it further, of course, Europe has these NCPs, National Climate and Energy Plans. What we also mention is that digitalization and AI should become also part of that.
Okay. Great. So I'd like to go a little bit through this data value chain. So we need access to data, we need computational power, we need models that we are using and algorithms that do the work in the AI. So if you go through that, where do you feel is the most room for potential improvement and further development, and maybe also looking from a regulatory point where the regulation can chime in and improve the market from your perspective? Who'd like or had ideas on that, Matej?
So with respect to the data, I would say that it's definitely currently very fragmented, and there is a lack of unified formats and especially event taxonomies. This has caused, I can give you an example. We had to implement a project for a large supplier, and it took 2 years just to do the data automation from the DSOs, whereas the project could have taken 3 months. So secure and interoperable data access rules are definitely needed, and as you well said at the beginning of the meeting, definitely cross-border. In my opinion, this over-regulation may slow innovation more than it actually protects the systems, and this is with respect to the data. Now, what I believe can be done to help out, in the long run, you will have to look at investments in the infrastructure and telemetry, because that's where you will gather the data. But in the short to medium term, you can look at AI policies that will focus on the safe data sharing and not restricting it, enable secure data exchange, for example, and even provide regulatory clarity with respect to the EU AI Act, which can be interpreted pretty, wrongfully, because what we are building is very safe. We do not control, for example, the grid assets, so there's nothing risky there. So this way of interpreting the risk is very important, and I think allowing innovation-friendly procurement pathways is also very important, because we had situations working with TSOs where they wanted our solutions but could not purchase it, even though it outperformed them, just because they have these lengthy processes, and it's it's backfiring now on adoption of technologies.
Okay, thank you. Very clear recommendation. Who else would have a take on data and models and things that how that relates to regulation?
I can just quick go. So we see more and more available data, actually. So that's really good. We have more than 6,000 data layers in our platform, so that's super. However, it would be great to share more data so companies can rather spend time on evaluating it instead of finding it, right? But what we know is that, of course, many things in this sector is confidential, both because it's internal, like where you're going to bid, for instance, is confidential information, and also a lot of, as you mentioned in the beginning, infrastructure data and grid connections, etc. But some data is also possible to share, like seabed data, for instance, and it would be nice also, as mentioned here, if the regulations across countries could be more similar, so then it's easier to kind of scale softwares and platforms across countries in a more easier manner and more efficient. So, and I also just read about an EU project with researchers from Aalborg University. They're going to collect data for offshore wind that's going to be used across the whole world, and such initiatives are super. So that's good for the whole industry.
Okay, great.
If I may
add. Lorena.
So what we saw, it's of course that actually utilities and OEMs, they develop in-house solutions. And we have looked actually for the models perspective and scenarios. And we have to take into account the fact that the training of the models which are used for the power sector is not, because it's underlined by a physical layer, it will not work probably completely like the ChatGPT. So we have to find, so we have to find those solutions which can actually are open, but on the other hand, to allow those who still need to protect their data, to make the solutions inside. So a kind of hybrid partnerships where we combine actually this domain of expertise in AI, but with the request of the power system. So if I stop here.
Okay. Yeah, thanks a lot, Johnny. Anything to add from your side?
No, I think everyone has already mentioned what I was thinking about, but basically data being fragmented, interoperability between us as an aggregator and let's say utilities and other actors in the value chain. Scalability is kind of the common denominator for our challenges in that, like how do you scale? But I'm not only like across EU, but also actually within Sweden, or even on that level. So but yeah, I think that's
okay, perfect.
from my side.
Okay, then we heard in the beginning that there's a particular interest in foundation models, and we see that as very relevant in the LLMs, but we're also talking about time series data, visual imaging, so there are other types of data that might be relevant. So yeah, I'm very interested in how foundation models are relevant to your business. Matej, you already touched a little bit up on that, and also on how your ideas on, well, usage governance structures around foundation models could be.
Basically, everything that we have built was built on foundational models. So we have things like weather to power models or operational performance models, and they are trained on time series data. They are not resource intensive in terms of energy costs. So it's really a great technology to be used. And we will not need, let's say, the large language models in order to perform these activities, at least in the energy sectors. The characteristics of the models that we use are physics informed, for example, which combine machine learning with knowledge about the energy systems and how they physically work, for example. They are adaptable, meaning that they will fine-tune themselves in time as long as we add more data and into them, and they can learn from more data. And of course, they integrate multiple sources such as weather data, telemetry, grid operational information, and so forth. The expected, let's say, impact of them is that they are more accurate. We have much more accurate forecasts under both normal and very, complex weather conditions. Helping TSOs, this came to my mind. We have really earlier detection in the performance loss of assets, better coordination between the renewables and the grid operators, and even the lower balancing cost. As my colleague very well said, Johnny, at the beginning, I truly believe that you need a single point. You cannot look at AI from a single point down the value chain, and you really need a coordinated strategy for the whole value chain in order to really reach its full potential. So this is my take on it.
Hilde, I saw you nodding, and it seems you're operating a lot of different data sources as well. So
yeah, we have a lot of data, but I think the interesting part to talk about in this right now, maybe it's the wind data, which is where we're using a lot, of course, to predict the development possibilities. And I mean, in some cases, in the very complex terrain, you need to do measurements. But now, actually, also some companies starting to do more better simulations. For instance, the company called Wiffle in the Netherlands. So such initiatives where they can provide better data instead of going out and measure it in an early phase. That gives also the speed to do more development earlier. So yeah, but we have a lot of different data. So you talk for hours.
Okay. Right. What about access to these foundation models? Is that something that you're concerned about, or where you think that needs some governance around that?
Personally, if maybe it's for Hilde, but personally, I think everybody has access to the models. So it's the way you use them and how you feature engineer around the models that will really bring the success. It took us, honestly, about 2 to 3 years to outperform all the traditional companies that were forecasting with non-AI. And I believe that if we keep this up, we really can outperform by even more and more and more every year with new models that come to the market, new ideas, and let's say new methodologies of using the AI itself and the pipelines.
Okay. Great. Norela, has foundation models been an issue in your work considerations?
No, in our work, no, because we just do the technical, assessments. But of course, when you implement, then probably it's needed. And I would just would like to underline what Matej was saying. So of course there is the need to cross the data between the different layers, the business layer, the operational layer, asset layer, in order to optimize and then to develop new use cases. I think it's very important, and of course to optimize the forecasting, to optimize the planning and so on. And what I think it's important, especially for the system operation as such, it's that AI and of course the computing power can help in supporting reducing the simulation times you need when you operate these very complex systems. So this is what I would mention here.
And I'd like to stick with the business layer that you mentioned, and this hybrid structure that you also said in the earlier answer, where you have to have something open, have something restricted, maybe, and that would be, I think, an interesting insight from your company experience. How do this AI evolvement and data access, computational or access to computational power, how does that feed into your business model, and what's your interest in there, and maybe what are priorities on that? Yeah, Matej.
So yeah.
I know, would like to go first, Matej, maybe.
Yes, sure. With respect to basically the training as we do it today, we are using cloud services such as AWS, and they're not very resource intensive yet. And what we have built, and what we deliver is mostly through processes which are not very intensive. How it fits into the business model, we basically just put it into our pricing, and it covers more than enough. What we get through what we get paid for. So we have a SaaS business model, and now we are even having KPI-based performance models where we can get compensation for performance. And this is working out. If we spend more to train more, to do more research, etc., this should ultimately be compensated for the KPI mechanisms, which I see are very attractive for the players on the markets and the operators. But we do not have very resource-intensive trainings, and this is the great thing about foundational models, that time series models that are trained and not the large language models.
Okay. Actually, well, the talk is about, or we have AI factories and really large computational resources. So do you see applications where this should be used within energy applications or renewable integration?
Yes, I think you could use them and maybe sponsor startups and other companies to be able to use this infrastructure for the research. And yes, this would be very helpful, because a lot of the researchers, especially in startups, they do it on their laptops at the beginning, and they do not have the right infrastructure for this. And using AWS or other cloud providers is very expensive. And this is my biggest scare as I'm scaling my business, is that I will be working for Amazon in the future and not for my own company. So this is the biggest scare, and this was actually also discussed in the British Parliament, where we took part in the roundtable, and this is their greatest concern as well.
Okay. Norela, you were about to say something as well.
No, I think this is the point, because I'm thinking now about the TSOs, when they have to do all these simulations, and when I'm looking at my former colleagues in NSOE, which mentioned that we had 1 million hours of computation, then I said maybe there is a way to do it a little bit faster, because I think this can in principle reduce, of course, the cost, and then can optimize better, to reduce the balancing needs and all type of services which have to be provided.
Yes, time to market will be a different thing. So it's a big help, especially to institutions. Now that you mentioned it, I think it's of a big help. I do not.
Actually, I lost some connection.
Yeah, me as well. I just see you.
Or or maybe the others did. So just in case, Norela, that we are the only ones left on the meeting right now. So have you received feedback on the 5 clusters when you published the report, and when you talk to the other governmental bodies, how? Okay, you're back, Matej?
Yes, it just stopped for everybody, but we could still hear you. So we heard everything that you were saying.
Great. So then we continue with what you were saying. Was it?
I think I was just finished.
You were
actually.
okay.
Yes,
Perfect.
I think so.
So then right. Maybe Johnny and Hilde, would you agree from the business perspective that computation with cloud services is reasonable, feasible, and where would you have, or would you have other issues to add to this business side?
I think I agree what's been said, and our business is based on heavy cloud computations. So of course we're trying to do the algorithms as efficient as possible all the time, so we don't spend too much money on it, but it's an interesting topic.
Okay.
Yeah,
Also,
I can conclude. Sorry, but from Emily's perspective, we do not have those as a bottleneck right now, so we do not do that. But obviously, it is challenge, but it's not our main bottleneck.
Yes, I think what you caught me off guard, what I would try to say is that I do not believe in utilities that want to produce their own AI systems. We have constantly outperformed teams of tens of people in large utilities because this is a very specific know-how in how to build foundational models and pipelines. So with the cost, our application can cost one resource a month, and they have tens of people trying to fight with that, and they have a different business. So I would not go into software development and everything like this. I would limit myself to having a forecasting department which handles different applications, and they receive the forecast and then they perform better with the use of them, but not to build departments. It's very difficult to, you have startups that specialize in this and they struggle, and then the utilities think they can do that, and it's going to be a failure in the long run because the solutions are much cheaper than hiring a whole team to take 0.2% extra. You will lose money more than you will make, for sure.
I so much agree with you, Matej. I've seen that so many times. So yeah.
Okay. Yeah, well, then in the beginning, we also started about data and data sharing as a key prerequisite. And you said there were fragmented data. I heard there's also data quality is an issue if you have access to the data. So there's also this initiative of building the European energy data spaces. Is that something that connects to your business and that is helpful to you?
Amazingly helpful. So the unbundling has really hurt the suppliers, and I would see them as the biggest problem because they do not have access to the measurement data. They cannot do their billing. They cannot do their forecasting. It's really very difficult for them. So having consistent formats and the transparent way, secure way to share the data from the DSOs to the, let's say, to the suppliers, and also even the forecasts from the renewable assets to the TSO, even though they are probabilistic, they will have a huge impact, and they should, make the management of the grids a lot swifter. So yes, this is the starting point, and it's a very, very good starting point. Fully agree.
Okay, great. Lorena.
So completely agree. Of course, the interoperability and I don't know, harmonization. I would go first for harmonization of the data. I don't know if standards, so the data standardization. Yes, but this is a more lengthy process, I suppose, than harmonization. And what I would maybe still like to mention on what you said before. So once again, putting together these utilities and AI startups, whatever we have in Europe, I think it's an important path forward. I would also like to mention maybe what I think it's important is also to try to quantify the benefits. We had a lot of discussion, and for this reason in IRENA we developed this qualitative framework. So to quantify the benefits in terms of savings or cost reduction in order to be able to push it forward in the policy making area, and skills. But in the energy electricity sector, we do not have actually the AI experts. So I think this is important actually that we bring together. Otherwise, of course, Amazon and all the other companies, they will take them over until we develop.
Good. So as we are nearing the end of our session, I'd like to give the opportunity to each of you to, state one wish that you'd like the European regulation to develop towards. And yeah, maybe if there's issues that we've not tackled up on, have the opportunity to mention that. So yeah, let's have another round to talk about that.
I can start. I don't have a specific wish, but I think in general, I think it's really important when we try to make such things, and when the EU regulations wants to contribute to something, that's great. But first of all, just not make AI for the sake of AI, but actually solve a problem. And secondly, also researching what's already existing in the market, because there is a lot of solutions that can be used. And I think it's important that private companies, industry and researcher are working together instead of kind of doing their own path. And then we can make the industry move really forward. So I think this session here is a really great start to just sit in the same room and discuss how to move forward together. So I guess that's my wish.
Yeah, thank you very much for that.
Johnny, do you want to go first?
Sure, I can take it. And I think from our perspective, I don't have any, let's say, concrete wish as well, similar to Hilde there. But generally speaking, from our point of view, it's all about obviously reuse what we already have, but then also making sure that we can work cross-functionally, so to speak, across the entire value chain. I think that's, from our perspective, the most important thing for our, let's say, daily working going forward. Yeah.
Sure. And from our side, now that we talked about the coherent data and, of course, strategy along the value chain, I would say that regulatory sandboxes would be very useful for testing the AI technologies in real environments with the, let's say, operators, as well as, clearer procurement and more, let's say, easier to deal with procurement strategies when these operators want to choose certain technologies that they've tested in the sandboxes and want to purchase them and not having to be stuck to another vendor, which they do not want most of the times.
Yeah.
From my side, energy for AI or AI for energy, but I prefer maybe the second, AI for energy, to support the energy, and of course, energy for AI. I hope that we have, of course, the electrification needs, but this will go down with the time.
Yeah. Okay, then thanks a lot. I understood there's a lot of potential in the very beginning of the value chain with the creation and development of wind farms. We have within the distribution, with the households, with the retail sector, for TSOs and DSOs. So there's, across the entire energy sector, there are vast application potentials. We have currently access to foundational models that enable a lot of applications and benefits. There is already a lot in the market that is available that we can make use of. We'd like to have some clarity on regulation and reduced risk, and understanding the regulation is maybe something. And Matej, what you mentioned, regulatory sandboxes, trying things out is something that helps new startups. I hope this sums up pretty much of what we've said. Thank you very much for the discussion and for the work you are doing. I think it's really interesting to drive this technology and into the applications in the energy economy. So yeah, thanks a lot. And with that, I think the next part of the agenda is a short break, and we will regather here in 5 minutes. So thanks a lot.
I am a research project manager in the Energy Transition in Cities Department at CENER. This is the National Renewable Energy Center of Spain. So, well, as an introduction, as you know, buildings are becoming data-rich ecosystems where AI can bring not only smarter use, but smarter design, maintenance, comfort, and renovation strategies. Today, we'll explore how AI is transforming the sector, what barriers remain, and how Europe can accelerate safe and impactful deployment. This session will be quite similar to the previous one, but this time focus on buildings. So for this, I would like to introduce our 4 panelists for the session. These 4 experts in the field. Marion Blayo. Marion is an expert on AI for smart buildings and smart grids. She's responsible for leading AI and machine learning initiatives for the digital buildings department at Schneider Electric. José Laloya, EMA Group President at Train Technologies. In this role, he has full responsibility for the strategy, operations, innovation, and performance of the commercial HVAC and transport businesses in EMEA. Christian Rostro, lead data scientist at Siemens. He's focused on connecting people, products, services, and software across Siemens smart infrastructure by building scale, data, and AI products. And Kees van der Beer, Vice President Group IT and Software Development at Brunata. Brunata is a Danish clean tech company specialized in measuring and optimizing energy consumption. It leverages data, intelligent technology, and IoT solutions. Well, now that we've met our panelists, I'm looking forward to hearing their views on this topic. So, as an introduction, similar to the previous section of the workshop, as introduction to the current landscape and potential of AI for buildings, our first question for the panelists will be, what is your view on the current state of AI in buildings, and beyond energy services, where do you see the most promising applications? And which of them could have the largest impact if scaled up across Europe's building stock? So, yeah, I give you the floor. Maybe Marion, could you start with your vision about it?
Yes, for sure. Hi everyone. Good morning. Effectively at Schneider, we see AI, especially in the line of business digital buildings, as a transformative force across the entire building cycle, the entire building life cycle. So we are seeing ourselves as digital partners to help our clients go through digital transformation for AI and electrification for their buildings. And we, with that vision, have AI as a central core in it. We don't see it as a technology that we have to implement. We're always starting by a business case, and we're always seeing what is a need. So one of the strongest needs, as you were saying, is still smart energy services. So we're still looking for control. We're still looking how to make a building smart to make sure that we can save energy, and we have achieved great progress on that field with great result, like 50% of energy savings on some buildings. But as I was saying, we are looking for the entire building life cycle. So we're also looking to enhance the occupant experience with air quality. That was a hot topic during COVID. With predictive maintenance, when we have on our assets of building advisor, we're looking for asset health, alarm health, how we can do predictive maintenance with those data sets. But also looking into engineering and onboarding supports. There's a need at the beginning when we're starting a project to have AI assistant that can reason over documentation over sensor data sets. So we're looking at this as an entire project lifetimes with the onboardings, with the operation side, and finally some retrofit. So there is the possibilities and opportunity for AI in all of those aspects.
Okay, very interesting, Marion. Yeah, to see like the whole building life cycle. Yeah, it's a good point. Okay, next maybe Christian, for instance.
Thanks for having me. Was also driving the data and AI strategy for our Siemens Smart Infrastructure unit. So we start with the buildings, and as Mario said, across the life cycle, you start with planning and design phase. And already at that stage, you can use AI to really figure out what are the materials in brownfield sites that can be reused with 3D models, with identifying materials with AI, and then pinpointing where you can do something, where you need to put in new material, but where you also can keep the existing material. And so really working on circularity, right? But then, of course, in the operations and maintenance phase, we really need to double down on energy consumption. HVAC is probably the most dominant asset, but we're also seeing airflow being the new thing, because at the moment, everybody's going 100% on airflow, but I think we can also manage more on making that more flexible. And of course, asset management, refurbishments of assets is a big topic, making sure that the HVACs really run with the latest fans, with the latest technology, so that we keep them energy efficient. And then lastly, obviously the integration into the energy system. It's not just about how much energy that they consume, but how much renewable energy they consume, how they can also support the grids. We have heard that in the first panel, making sure that AI receives the right triggers from the markets, flex markets, congestion markets, and these type of things, and integrate that even to a level where you say you heating it up, the buildings, or cooling them down just for stability of the grid. Yeah. Always in line with the comfortability bands. I think this is where we can double down then later on.
Okay, thanks. Yeah, also, no, somehow this life cycle approach, design, construction, maintenance, ensuring energy efficiency, and refurbishment or renovation when the life cycle of the HVAC system has achieved. Next, maybe Kees or Jose. Yeah.
Thanks. I'm already unmuted, Jose, so I will take it first if you don't mind.
Okay.
Yeah. So our business, like Marianne also stated, we are in the buildings. So we are in the shell at the end user with the smart meters, heat cost allocators, water meters, electricity meters, and so on. We have we act on the behalf of the building owners at the end user level. So our data must be very precise without latency, and it's what we build mainly our machine learning models on to detect errors and predict maintenance as well, but also look for the improvements of the total building heating expenditure. That's where we see a great possibility for AI to see what can we do with the end user data and accumulate that for the entire building, especially connecting that to other grid data.
One question is, predictive maintenance based on AI solutions is a reality, or is something that you are working on it?
Yeah, it depends a bit if you where you put the division between machine learning and AI. I mean, at the moment we're quite advanced with the machine learning structured set. What I think we could definitely benefit with AI from is more the end user engagement. So making it more tangible for them to see what the energy consumption can do without losing comfort in their homes.
Okay. Thank you, Kees. Now, Jose, please.
Yes, so at Train Technologies, obviously we're in the commercial building space, so we have a very large installed base of HVAC equipment in EMEA and in Europe in particular, and we have over 60,000 assets connected. So we see a big potential for AI in let's say the operation of buildings in a more efficient way. I think we have to start with the premise that over 30% of energy is wasted in buildings today because buildings are not properly maintained or properly controlled. So really that 30% is a big number, and with the using predictive AI tools and also generative AI tools, we believe, and we have many examples, I can talk about them later, of how we can really go after that 30% energy waste in running these buildings more efficiently.
Okay, thanks. Yeah, thank you for those insights. I think, all of this gives us a really good overview of where AI in buildings stands today and how far it can go beyond energy efficiency, but also focus on energy efficiency, I think, but because it's an important pillar for this. Let's now move on from what's happening today to what might come next, specifically regarding the technologies and business. Similar to our previous session, I would like to ask you about foundation models. Do you foresee foundation models in this field, or will AI in buildings remain domain specific? And if possible, if you could link this to the next question, that would be, what is the business model for this type of application in your field, in your respective companies and so on? Maybe we could start, reverse. Jose, do you want to start giving us?
So we recently acquired a company called Brainbox AI, which is what we consider one of the, let's say, more unique and maybe even the first AI company really dedicated to HVAC. And they have some foundational models around, doing autonomous controls of buildings. And what we've found with as we connect more customers to this, what we call train autonomous controls now, the way this works at a very simple level is that there's a lot of data coming from all the equipment in that building, HVAC equipment in that building. And as I was saying before, we are connected to all of that equipment. So you have millions and millions of data points coming through every 5 seconds or so. And then, so we collect all that data, the AI models analyze that data, and they're also looking at other external data like weather data, for the future, but also previous weather data, and then making making adjustments to the control of that building to better, to adjust set points on a continuous basis. And we're talking sometimes thousands, and in very large buildings could go into hundreds of thousands of set points that are continuously being adjusted. And that can only happen with an AI tool that we have with the Brainbox. So when you continuously adjust the building based on what's happening with occupancy and loads in the building, and also what's happening externally to the building, mostly weather related, then you're going to have a much more efficient building than if you were just there, just with a basic on-prem control where there are set points that are very static, let's say, in nature. So we have seen with some of our customers that when they join this program, that they get 25% energy reduction over time, and we think that this can be improved even further. Some of our customers, newer customers, we've seen up to 40% energy reductions as they come online with Brainbox AI. The other thing that's also, I think, very important in this AI space is the generative AI side of things, and where we can create agents to better help our service operations people in servicing the buildings that are under our control. So we have a generative AI called Area, which is basically an assistant for a service technician. So with this assistant, before the service technician gets to the site, they already have all the information about what's going on in that building's assets, and it will make recommendations on what problems to deal with first. So it can be very basic things like, go and, the damper is stuck on, air handling unit number 2, or you need to go look at the fan in, rooftop number 3. But it allows the technician to be much more productive and attack the problems that really existing already that may be missed or could be attacked at a later point if it wasn't for the AI assistant. So we believe that if these two things scale dramatically in our industry, then buildings, we can really take this 30% wasted energy out of buildings.
Okay. Then I understand this AI assistant would be for the responsible of maintenance of the building. So maybe it's something, with the BMS of the building, and attend or guide the responsible of maintenance, to adjust the set point or check the warnings of the systems or something like that in the BMS.
That's right. Yes, that's right. And it can be the building owner, but it can also be our own people, right? Because if it's a connected building, as I described before, with the train autonomous control, then we already know what's happening in that building and what are the problems, and we can go and start to address them proactively.
Okay, thank you. Maybe Keith,
Yeah, I can follow up on the train of thought Jose started. So we are in the residential area, and we have the same amount of data coming in, high frequency, realistic data. Where I can see where we could really contribute then is to we see the same sort of savings. Entering sub-metering devices in a building leads to a 10-15% of reduction just by making people aware. But as stated before, there's also still a lot of heat loss, energy loss going on in the building. What we have discovered is that it's due to a poor utilization of the heat within the residential apartments. So not utilizing your radiators in a proper way is very difficult to adjust externally for a building owner. They cannot go in and turn on and off radiators as they wish. They probably would like that every now and then, but it's in the domestic sphere of the residents themselves. So and that's where we can see the additional 30% savings of energy if we could make the end users aware of proper utilization of their energy in their own flats. They have been trained over the couple of last years. You are being built fairly by what you consume, so turn down your radiator. What we now can see is that ineffective use of heating in the flats is just what do you call it? It causes very high return temperatures in some occasions, and to use those models, use all the data on a foundational model, you could either interfere if you have smart thermostatic valves by having a constant flow through the system, or you could make the user much more aware through agents, through applications that they should either use the energy more efficiently, or that they are actually contributing to a higher return temperature and thus adding consumption to the building.
Okay, thank you, X. Yeah, very, very interesting, no, in same approach, but for residential sector. Christian, maybe your point on this.
On the foundational models, maybe I think question is always what we talk about when we say foundational models. I think we typically try to talk about domain-specific models that use existing large language models capabilities and then trying to understand the building language, quote unquote, or making them understand time series like we have with foundational models for time series. But I don't see that we're now investing in large data centers that create that one big foundational model for buildings, right? But similar to Jose and Case, what we see in those Gen AI use cases is Brainbox and similar solutions that we're building is how do you engineer that fast? How do you have the service technicians that come on site, that understand the building data, that come with, this is what I need to do, this is how I pre-configure this. This is actually where Gen AI really will help us scale those solutions, because it's not just having that box or that algorithm sitting there. It's the millions of people that need to go into the building, engineer it, configure it. And this is then also when we talk about data layer, how do we make sure that we have the BIM systems, the administration, asset administration shell ready, and all this data standards in, so that we get much faster in scaling the individual buildings. Yeah, because this will also drive down costs, right? When you look at the end-to-end business case of the energy savings, then you have the algorithm, and then you have the people that actually maintain that. And that is, I think, currently the biggest challenge to overcome, getting that engineering and commissioning costs down, so we can basically just run through all the building, install the AI, and then you will have the 30-40% reductions that I think everybody's seeing, depending on the building size, the building on the age of the buildings.
Okay, very interesting point. No, the commissioning, no, also of the AI supported system. Marion, your ideas about these foundation models.
Yeah, foundation model is different. We think at Schneider is going to be a key enabler on our side. So we are exploring the fact of creating a knowledge-based model for everything that we have as we're collecting more and more data set. But we're always thinking of our business and our client first. So it's always business case first. So to come back to what Rosé have presented, is we are looking more as foundation model with the view of agents. Each data set might be specific, so we might have data set for alarms. We have my data set that are specific, that's coming from the BIM, from the deployment, and from the project at the beginning when we design it. So because we have those specific use case, because we have those specific data set that might be different during the life cycle of the building, to come back to it, we are approaching it more as an agentic frameworks, when we will have in one case a machine learning algorithm that will be helpful for analytics, and another one that will be more based on LLM for helping in creating an AI assistant. All of them bringing data sets and bringing feedback to feed a major model internally. That's where we're looking for. And because we're looking for at business case first, our approach to the business on this side is a bespoke model. So some of them are built internally with our experts, and some of them will be through acquisition or through partnerships. So there is specific niche, specific domain knowledge in HVAC that needs to be brought in by our partners because they have an expertise, and there are some that we can develop internally. So we are doing both at both sides. We are trying to develop what we call AI at scale. So we still have a group of people inside Schneider that are dedicated for building those models, dedicated for looking into it. So for foundation model, we think it's important, but we also thinking of creating it modules per modules, basically, based on the data set that we have available and based on the use case that we think our client needs and they might be interested in. So they might not need to know everything on the buildings. For the example, on the onboarding on the people that go on site, as Christian was saying, for example, for EV panels, you need a lot of clients, you need a lot of technicians that go on site, look at the electrical panel in the house, install an EV chargers. We have developed a technology that can just with image recognition, look at the panels, help the users on site with a user interface that is most likely useful to see what they have to do. What is the electrical panel? Can they effectively put an EV charger on it? So it is by those modules that we can help at the end collecting all of the data that we need for something bigger behind it.
Okay. Yeah, very clear explanation, Marion. Thank you. Some of you have already mentioned data, the need of data, data set, data layers, BIM systems, and so on. In this context, regarding the foundation models, what kind of data infrastructure for sharing would enable this aspect, this approach for foundation models? And also, I would like to know if you already know if there are current EPBD provisions regarding data exchange that fit for this purpose. What do you think about it? Maybe Marion, or you can first go ahead if possible. If you would like to add something, because I know you have already mentioned the data set, the different modules approach, and so on. So maybe if you would like to add something regarding this.
No, I think Christian was right when he was talking about data layers. This is like a really important steps when we do anything in AI. We need something that everyone can use and have it that oversee everything in buildings. As we were saying, we're going to have big data. We're going to have diagram that's look at the electrical, diagram that's look at the mechanical side of the buildings. We're going to have data set that's coming live that are temperature, airflows. We're going to have all of the assets of the HVAC. So we have a lot of data set that we have to come into a data layer that we can use for anything that we want to train. That's for sure. For data sharing between partners, for data sharing between the actors on the field, I think what might matter the most is interoperability, meaning if we are able to find a data model that will make sense and that we can share in the case when we have that legal agreement, because those data sometimes is owned by our client. So when we have that legal agreement, when we can share and use, then interoperability is a key word, I think, in data sharings. If we have common models, for example, and common protocols of how to communicate, In our field, for example, obviously BACnet is our common protocols. Then we can open APIs to have access to that data layers. But also within the data model, we are looking at semantics. We are looking at ontology that we can reuse all the times. So at Schneider, we use brick schema. But we know it's not always the case. Not everyone is using the same standards for the data model. So there is these things as interoperability when we have access to the data, when it's legally agreed by the clients to be shared. How can we interconnect all of this data together with all of the stakeholders, and how we can make sure that it's make an onboarding faster from a client perspective, but also from our fornisher for any kind of data sets or any kind of services that we're looking for.
Okay, thank you, Marion.
Yes,
okay.
maybe I can. This is Marion was spot on with what she was saying. I just want to, take a tangent on what Christian just mentioned before about data center build out. And in Europe, unfortunately, and I've discussed this with a few of the EU commissioners here in Brussels. I think in Europe, we're falling way behind in the data center build out compared to the USA and compared to Asia. And everyone is focused about how data centers are bad because they're going to use a lot of energy and they're going to use a lot of water. And by the way, I just want to dispel the myth right now. We can make data centers that don't use any water. Okay. So I don't know. So if, as a group listening here, this concept that data centers are going to use a lot of water is just false. And we should really stop talking about that. Now, will data centers use a lot of energy? Yes, but will they? But today, data centers are using 2% of the energy that's available, and yet we just finished talking about the 30% waste that's going on in buildings. But to do all these wonderful things, we need to build data centers to be able to create these models, more extensive models, do all this data sharing. And unfortunately, in Europe, the permitting for new data centers is very, very difficult compared to what's happening in the United States and in Asia. And if we don't build the data centers, all of this other stuff will not happen in Europe. And for me, and I've said this to, as I mentioned, some of the people responsible for this, the data center infrastructure build has to be looked at like the Industrial Revolution was 200-300 years ago, when people were building railways. And imagine if the railways were not built 200 years ago, what would have the Industrial Revolution looked like in Europe? So, one of the big things that has to happen is we need to start to speed up the data center build in Europe. And a lot of that comes down to having, companies getting permits to do that, because today they're not getting the permits. And I'll just give you a little bit of an insight here. I work with all the big hyperscalers, right? As I'm sure some of my colleagues do on this call as well. And I see, these are global companies, and I see, we sell them chillers, in this case, to cool the data centers. And I look at the kind of, if I sell one chiller in Europe for a data center, my American colleagues and my Asian colleagues are selling 10 to 20 chillers for every one chiller that I'm selling. That means that they're building, 10 to 20 times faster than what we're building in Europe. And if we continue like that, we're not going to be able to do the things we're doing, or we're going to become a colony of, the US or Asia in terms of AI. So if we can have any,
just to respond to this. So 100% agree with your position on this. What I tried to say was, I don't think that for training the AI to predict energy and getting those 30%, maybe you get to 20% with already a good build out of data centers. I don't think that for that specific use case, you need mega data centers to get there. However, I think we're switching not only to training, but also inference at scale. And I think the new data centers will not just be used for training, but mega inference on a large scale, right? Where we're not seeing, I think this is just one part, right? And I think obviously we need to accelerate data center usage and build out. And back to the data point, right? One is, of course, in the building, we need to figure out how to exchange the data. We have asset administration shell as one of the options to actually get there with a digital product passport. So kind of one standard where everybody speaks the same language on how these HVACs are configured, how the chillers are configured, etc. And then you need to find a format that also integrates well with the aggregators, with the renewables, with the electrification area, because otherwise this link in the system between the electrification and the building will never come to pass, right? And so I think this is why we need to double down on these cross vertical things. And of course, we need to increase the amount of building information management systems that are there and really capturing data already at the building site. When you build a data center, when you commission it, and when you design it, you have all that information with the electrical line diagrams, with the fire diagrams already in place, so that we don't need to have very complex engineering tasks, right?
Yes, I would like to build on that just with maybe a very pragmatic insight as well. Is that I agree with both point of views, all 3 point of views. That would be very nice. A digital passport for standardization as well. What we see very much when we act on the behalf of of the building owners is that they have a very fragmented technology support from different kind of systems. Many have legacy systems, so for them to actually deliver to this digital passport, there's no incentive for them. There's no need, there's no push that they could actually come upscale besides missing out on business. And that might also be beneficial that then not only is an opportunity to deliver with a digital passport in a standardized way to the data centers, but there's also a push that it actually is mandatory to come up, get out of your legacy platform to actually be able to deliver to those beneficial data models.
Thank you, Kees. Thank you. Excellent points, all of you. Very interesting views. Good to see, how data interoperability and new business models are starting to converge. Although we have a lot of work ahead. You already mentioned several barriers, for deployment and so on. But I would like to go a little bit deeply in this context. So my next question is, what are the main barriers preventing faster deployment of AI solution in buildings from a technical perspective, a regulatory perspective, or something market-related perspective? It's true that you already mentioned some of them. Also, for instance, are building owners and operators, maintenance staff, for instance, ready to trust AI-driven decision-making, for instance, or do we need a stronger cooperation, for instance, between manufacturers, data providers, and public authorities? What do you think about all of this? For instance, Christian, could you start and give us your overview?
I think one is certainly also investment. I think it depends a bit on the size of the customers, but specifically the smaller building operators, right? They look very much in how much can I invest, and what really helped in some parts was the ISO 50001, making sure that everybody needs to install energy management regulations, and I think this type of incentivizing energy monitoring systems already help, because typically if you don't connect the HVAC to an energy management systems, you even don't know, are you saving 10%, are you saving 5%, are you saving 50%, maybe 60%, right? And I think really getting the IoT in, getting the connectivity in, connecting to the building management systems, and then having kind of a TOTEX approach where you say, okay, you can capture both investments in software, but also investments in hardware as deductions, really helps especially the smaller building owners to really get going on that. Yeah. And then in terms of AI safety, yeah, I think on the AI Act, we're currently seeing mixed signals. Some customers are really looking for the industry standards, really saying, okay, we need something like we had with cloud, like the ISO 27001, kind of really standardizing how cloud can be secure. We see similar things with ISO 42001, where people just standardize how AI is used, right? So a CE certificate might not be enough for some customers. They want to see how securely are you actually operating it and following industry standards that also help us to then shift to the US market, shift to the Indian market with one global ISO standard on how we run AI. Yeah.
Okay, thank you. Maybe Kees, could you go ahead with this?
Yeah, that's just touching on the security part of it. That's I agree with Christian. That would be definitely beneficial as acting on behalf of the building owners. They already have a demand that we do the 27001 as well, like the GDPR insurance. Also this 27001, of course. I think that could be very beneficial. I think what would be from our point of view for sure is a barrier at the moment is the consent that we need from individual tenants. So GDPR, very nice. We act on behalf of the building owners to secure the data, but it also restricts us from having all that data and sending it to, for example, third-party buildings to more efficiently operate the building. So there's definitely a barrier. There's also proposals and solutions for that barrier to share that data. Of course, it's private data, but it could be anonymized or pseudonymized. That would be no problem. So that is for sure a barrier to get forward to this.
Okay, thanks. Marion, what do you think? Are main barriers for faster deployment?
Yeah, for faster deployment, I think there's also a bit of skill gaps on the workforce. So many people are when you're in the building, it's an old industry. Sometimes it's not easy to understand what AI can bring to you. So it is interesting, like when we're talking about investments, interesting to understand that you don't necessarily have to do an entire retrofit of your entire legacy systems. With AI, you can already on the operation side, on the management side, it can be an enabler. So we have that gaps of understanding, like AI can be an investment, and sometimes you need incentive, as you're saying, Christian, to go into there. But sometimes it can also help you to avoid bigger investment on a track because it can help you for the operation and maintenance. So there is those two facts, and highlighting it by taking action, or by taking a lighthouse project that can showcase in the European Commission what we can do will be definitely interesting. The other point on KISS was definitely interesting as well, like the data scarcity or data fragmentation with a lot of rules that we have to comply with, which is normal. We have to make sure that the data is secure, is high quality, and is well in place with our clients. Sometimes can limit a bit how much we can go up front, but that's a discussion that we can have with the client as well, and that's a moving forwards movement. So what you can do with your data, which one you agree to share, and with those, what you can do, which algorithm or which features you will be able to enable. So I will think there's that gap in the workforce of understanding what is AI and how it can enable it. And then data fragmentation, data silos, it's always something that exists.
Yeah, if you can just add to that as well. So you asked the first question, Maria, is the data there that can be, so that AI models can be trusted? I mean, I think all the end devices, they are there. The digitization of the buildings has been in place for a long time. So that creates a very solid foundation for AI's data to build on if it can be shared.
Okay. Maybe to a question in the chat, right?
I was exactly looking at the same. Yeah, maybe, but Christian, go ahead. We could say that is regarding cybersecurity.
Yeah. So maybe on cybersecurity, right? I always compare this between leaky Fort Knox and governed openness. So what we have right now in the buildings is it's very hard to get sometimes data out of it. Some people draw Excels out of it. Some people take dumps out of specific assets with USB sticks and this type of thing. So it's a really brownfield thing. And this is so it's very hard, right? You can't go into the internet sometimes and get the data out. So it's essentially a Fort Knox, but you get the data out in a very ungoverned way. And what we want to move towards is more governed openness. This means all the systems have proper APIs, proper REST APIs that you knew from the web. So you don't need to know BACnet and you don't need to all those special things, so that also the new kids on the block, the aggregators, the renewable companies can actually access this, right? So we need to have the APIs out. We need to have proper data layers with OData and these type of data pipeline languages and as Marion said, really exposing it with agents, with the new model context protocol, really transforming the building into something that's governed but open enough that everybody can connect to. And then you have the new NIS2 regulations, CRA, where you really make sure that those open protocols are secure. You have the cyber experts in, and yeah, I mean, it's really hard work to get everything this secure. You can imagine we have large departments that are doing nothing else but making sure that everything is secure. But yeah.
Yeah. Okay, thanks. Jose, to finish this block, barriers and cooperation needs.
Yeah,
What do
no,
you think?
I don't have much more to add than what my colleagues discussed, but I think the talent is very important, that we continue to develop, the right people and educate the people to really get into this. And then, at the end of the day too, there's a very complex situation, and there's a lot of inertia in the industry, especially in the existing building industry, that we need to overcome. And I think everyone looks at the physical assets, and there's lots of regulations about making the physical asset more efficient. But I agree with what Christian said before, that I think sometimes you can have the best physical assets, but if they're not connected to some sort of sophisticated BMS system or eventually an AI-based system, you're not going to get the energy savings you need anyway. And maybe some more discussion, which is what we're doing today, but more broader discussion around, we keep pushing for energy efficiency at the component level, but we should also start to maybe understand how many buildings actually don't have BMS systems or complex BMS systems, and start to put in some metrics and regulations around that, right? That if you have a building of a certain size, you need to have the latest version of a BMS system, because that will then eventually drive efficiency of the components in that building. And I don't think as an industry, at least from my point of view, we're really looking at it that way, right? We're really driving efficiency of chillers or heat pumps or air handling units, but not the whole BMS efficiency.
Okay, thank you. Yeah, good point, Jose. Well, very very interesting point. I think you have highlighted clearly key aspects to take into account, and this brings us directly to the question of what can be done at policy level. How can the European Commission help accelerate progress in a safe and a coordinated way? How can the European Commission best support this safe and swift deployment of AI for buildings? I would like to know, what do you think about if the current EU frameworks, for instance, the AI Act, Data Act, the PVD recast, do you think are sufficient to enable innovation, or do we need other target actions? And finally, very last question would be, if you could recommend one practical measure to the Commission, what would it be? Okay, to finish this section. So, who wants to start? Maybe Marion, for instance.
Yes, thank you. So on the on policies and on what can be done. So we talk about just before the smart readiness indicator. I think it can be pushed forward because it presents what you need in a building. So as we were saying, how many are connected, how many BMS we actually have. But AI is progressing quite fast. So I think we might need to update it a little. As there is connectivity, we need to have IoT software, we need to have protocol to make it work. But the new protocol that's coming into the business building data layer is definitely important right now. So there is new thing that on that indicator could make your buildings ready, as the threshold of future ready is just moving forward. So I think those indicators could be moved a bit. I'm not sure if it can be, but incentive or data sharing, incentive and pushing forwards the open standard for communication, as Christian was saying, to make sure that we can open the communication not only for buildings, but for power as well and for the grid interactivity. Finally, maybe funding a few lighthouse projects, just to help skills development program and educate people of what can be done, because there is many things that is said, but it's always interesting to build the trust with everyone and the client for adoption. So a few lighthouse projects can always help, showcasing how far we can push and what needs to be done. So I think that's the one that I think will be interesting.
Okay, thank you, Marion. Yeah, I totally agree. Well, Jose, maybe.
Yeah, I'll just very quickly, I'll say what I said before. I think we need to accelerate the infrastructure build out in Europe, especially around data center construction, because this is the foundation to everything else, and this is going very slowly compared to what I see in the US and in Asia.
Okay, thanks. Christian, what's your final recommendation about it?
Yeah, right. I think scaling the data center is one thing. Scaling also the energy infrastructure will be critical for the buildings to connect to the grids with proper energy. I think then on the smart readiness, that's a great idea. I think this is something we need to increase. The main thing, and this is true also for the AI Act, we need to find some national harmonization, because we can't build kind of smart readiness index for each country. It's very different, and we need to find some way of keeping it harmonized on a EU level, to really get that scale in, and then digital product passport, AAS, making sure we use more BMS systems and finance this for the building owners.
Okay, thanks, Christian. Yes.
Yeah, not much more to add than that we should focus on data sharing, standardization, preferably make it mandatory to have a higher technological standard, like Christian said, just a RESTful, so everybody can join in. Also penalizing maybe the companies that cannot deliver, and of course balancing the data privacy, but more focused on that it actually needs to be focused on reducing the energy consumption.
Okay, thanks. Many thanks to all of you. Those are really valuable messages for policy makers, I think. I keep, or my highlights from this last point would be incentive the data sharing and open communication. Okay, about upgrade professional skills, program educations, and so on. This is a quote that we use in European projects, that is open as possible, close as necessary, to maintain a balance between security and the needs, the system, the AI based support system needs to be deployed. So thank you all for your thoughtful contributions. It's been, I think, it's been a very rich and dynamic discussion. I have learned a lot, and I think we've captured the key challenges and opportunities ahead for the AI in buildings. So I think I will give the floor to Stavros, I think, who will provide the closing remarks for the workshop. Or
Hi, Maria. That will actually be me making the conclusions.
Perfect. Thanks.
Well, thank you. So my name is Mark van Stiphout. I am the deputy head of unit in DG Energy, in the unit that is, among others, responsible for digitalization. So first of all, I would like to thank all of you for making this a very interesting and a very worthwhile workshop. I think it's been, we had a bit of trouble at the beginning with the connection, so we're really sorry for that. Luckily, everything is recorded, so the recording will be available for if people want to look back at it and also see what they may have missed during the first part on where we're discussing renewables. So, but let me start by thanking you, Maria, for moderating this session, and Marion, José, Christian, and Kees for their contributions to the panel discussion. This was really very, very interesting, and I'll go a bit into the content later. Of course, I also want to thank Volker for moderating the first part, and Norela and Hilde and Swan and Matej for the panel discussion in the morning, and Anna from UREC for basically helping us with the organization of the workshop. And last but not least, of course, my colleagues for setting this up. For us, this is very important, this discussion, these type of workshops, to hear from the stakeholders where you see the need for action when it comes to making good use of AI. We are all saying that AI will be really a game changer in many sectors, including in the energy sector. I don't think that is very much disputed. But of course, we want to go beyond the buzzword and really find out what can we concretely do about it. Where can we as a European Commission and maybe in general as the public sector come in to make sure that we are really making this potential happen. Of course, for the energy transition, for the competitiveness of the European economy, while maintaining security of supply. So and then, of course, we need to go beyond the buzzwords and the obvious. It can do lots of things here and can lots of do things there, and get an insight into what is actually blocking and what is creating the problems. So for that, I think both discussions were really very, very useful. And I will try to summarize a bit what they are. I think it's fair to say that the morning session around renewables, you can also see, let's say, the difference in type of industry and the type of actors in the renewable industry, with big companies developing big, let's say, for example, wind parks, etc., who are, let's say, in the use of AI are maybe less concerned that they are able to use it and implement it, but it is more around how do we make it happen at a scale? How do we make sure that this AI is really taken to the next level, and that is not the, let's say, the artificial intelligence and the machine learning that everybody has been using already for a long time, but take it to the next level, talking about these foundation models and these generative AI solutions, and how do we make sure that they can really help, let's say, the productivity of renewables and also support innovation. I think what we took away from that discussion was that there is a need for rules for interoperable and harmonized data exchange in order to make cross-border sharing of data happen. That there is also an investment in hardware needed in terms of telemetry, in terms of infrastructures to be able to generate the data, but also create infrastructures that make this data accessible in the longer term. And make sure that the AI developers can help, let's say, the market parties or the network operators in getting the solutions that can help, that can really help them improving the performance. What was also clear from that session was that this cooperation needs to be along the whole value chain, and this is not a matter of let's say, just the wind park operators, for example. It is the supply chains, the equipment installers. The intelligence is always in many different devices, and it is only by really combining the intelligence of these devices that I think we can make the most out of AI. I think one thing that was mentioned repeatedly, and this was also in the earlier workshops, what really matters is the skills, and the right people with the right skills. I think when we were at the AI workshop, somebody put it very sharp, I thought, which is, it's not enough to just know AI very well, and it's not enough to know energy very well. What we are actually needing is people that know both, and that combines these two things. And of course, that is harder to find. But this is what, if we want to be competitive in Europe, then of course we need to attract the skilled people. and avoid that they, let's say, go away and just work, let's say, in the other big, drawers of talent, like, for example, these big tech companies that, of course, very dominant in this section. And if we want to stand up as in the EU, then we need to find a way to attract those skills and keep those skills in the EU. And I think the last point from that session on renewables, one thing that I think I want to highlight is the mention of regulatory sandboxes for testing solutions in real world environments, but creating some way to function outside of the normal regulatory framework to test solutions and to create trust in those solutions so that they can be effectively marketed. So I think this was for the first section. And then I think for the building session, let's say what I understood from it, it's also much more about really making, really still also pushing the use of AI. There it's not just all these building operators are already using AI, and it's more also how do we take it to the next level in terms of foundation models or generative AI. It is also still very much about the potential that AI has in optimizing the way which buildings are run. And so it can bring smarter use of energy in buildings. It can impact on the predictive maintenance, on the let's say onboarding of new assets, on working on the whole building life cycle, optimizing the energy efficiency, and there's a lot of potential there. And I think just now. I think it was Marion who mentioned flagship projects to really showcase what's possible. I think that very much speaks to our heart, because of course we are one of our responsibilities is also involvement in Horizon Europe program, involved in the Innovation Fund. So for us that is when it comes to using that funding for the energy sector, a lot of it is about showing what is possible. So I think that very much speaks to us. What of course we then need to make sure is that what is possible is also taken up, and that's of course where it gets stuck. And I think with our strategic roadmap we really want to look at how can we take those flagships further. So we need both, and we need to see how we can take it further. Again, also here data sharing was mentioned, interoperability was mentioned. The legal certainty that you need to have, for example, that the clients agree that data are being used, that data can be shared. And I think the general perception was that if we are able to share this data from the different parts of a building better, then we can really optimize a great deal. And it's not even about, if I understood it correctly, about developing foundation models, which is also something that can help, but it is just a matter of having models that already exist, feeding them with more data from different sources. So I think in a way, it's one step earlier in the process where we can still make a lot of gains. And then I think you made a lot of reference to things that are already ongoing, that hold a lot of potential, but that also need to be implemented well and with the specific sector like buildings in mind. The AI Act, the Data Act, the Digital Passport, in terms of standardizing the understanding of how the buildings are worked, what the assets do, and also then a way of integrating the legacy assets. The need of standards, of course, in data exchange, and the fact one of the existing legislation around the GDPR, and how do we make sure that people actually give consent. There are tools available to manage these type of things, and I was just with a colleague in Berlin talking around data exchange to make flexibility and for the energy system work. And of course, their buildings and heat pumps, etc., are also a big aspect of it. And in that discussion, we are also addressing how do you manage consent in a standardized way so that the GDPR is not a blocking factor. So all in all, I think there are a few key things, like make better use of the potential of the data that is already there and integrate it so that the software can basically work better. make sure that all these new things and this new legislation is actually implemented in a good way so that it helps building intelligence, so that it helps running renewables more efficiently. And then I think the next frontier, so to see, is also how can we make all that data and all that intelligence, how can we make use of it as the basis to create in the EU a sector or an industry that develops the next frontier in AI, like these foundational models or generative AI, in a European context based on data exchange that is built on the consent and on the joint interest of the different parties involved who have then an interest to jointly develop new solutions. That also, of course, requires investments in hardware or in digital infrastructures. There are legacy assets that we need to take into account. So it's not all just investments in software. I think I would like to be very clear about that as well. But in combining these things, we can really go a long way, and there's a lot of potential. So I think that is, for at least for me personally, the most inspiring part of the discussion. There are so many good ideas. And now it's up to us to distill out of that some very concrete things that we can do to help you. So that's our commitment. This is not the last conversation we're going to have on this topic. So I hope to see many of you again soon. And for now, I would just like to thank you for your engagement and for the interesting discussion. Thank you very much.